This video is prepared by Avya Classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIMS and NEET. Learn about perfectly elastic collision in detail. So let's two body of masses m1 and m2 are moving with initial velocity u1 and u2 in the same direction and they collide such that after collision their final velocities are v1 and v2 respectively. So it is shown in this figure. This is the case of before collision and this is the case of after collision. So clearly we have to apply the concept of first is the momentum conservation. I just noted down here momentum conservation. Second, as it is the case of elastic collision, so we apply the concept of kinetic energy conservation. And third one, we apply that the coefficient of restitution. So if you see later, we will see it later on that we get the coefficient of restitution concept from here, the kinetic energy conservation. So first we are applying the law of conservation of momentum, and as per this theory, the initial momentum must be equal to final momentum, as the collision is termed as a internal phenomena, or the forces in the collision is termed as internal forces. So initial momentum is m1 u1 plus m2 u2, and the final momentum or the momentum after collision is m1 v1 plus m2 v2. So if I write it equal, then m1 u1 minus v1 is equal to m2 v2 minus u2. So this is our equation 2, and it has already come from conservation of momentum. Now we will apply the law of conservation of kinetic energy, and as per this conservation, the initial kinetic energy is equal to final kinetic energy. So the initial kinetic energy is equal to half m1 u1 square plus half m2 u2 square, and the final kinetic energy is half m1 v1 square plus half m2 v2 square. Basically we are writing the kinetic energy of bodies before collision, and this is comes from this figure, and again the kinetic energy of bodies after the collision. So if you see this figure, then we get the value equal to m1 into u1 minus u1 square minus v1 square is equal to m2 v2 square minus u2 square. And if I divide equation 4 by equation 2, then we get, so basically we divide the equation 4 by equation 2, then we get m1 into u1 square minus v1 square divided by m1 into u1 minus v1 is equal to m2 v2 square minus u2 square divided by m2 into v2 minus u2. So from there we get u1 plus v1 into u1 minus v1 divided by u1 minus v1 is equal to v2 plus u2 into v2 minus u2 divided by v2 minus u2. So we get from there v1 plus u1 is equal to v2 plus u2, and from there we get v2 minus v1 is equal to u1 minus u2. So basically this formula we can get directly from the coefficient of restitution, that is the velocity of separation is equal to velocity of approach in case of a perfectly elastic collision. So clearly if we apply the momentum conservation and kinetic energy conservation, we get the coefficient of restitution, or the formula we get that the coefficient of restitution comes equal to 1. So from there we can write that the velocity of relative velocity of approach is equal to relative velocity of separation. And from this third equation, or the from this sixth equation which we have derived, that v2 is equal to v1 plus u1 minus u2. So basically we we have got three formula: one from the momentum conservation, one from the kinetic energy conservation, and another from the concept of coefficient of restitution. So if I use these three formulas, then we can get the velocity of collision, velocity of bodies after collision. So if I use this formula, first v2 is equal to v1 plus u1 minus u2, and put it, and if I take this formula, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. That is the formula for conservation of momentum. And if I solve, I will get the formula for final velocity. So I will just solve it here and show you how it happens. So first we will calculate the v1, and for this we just substitute the value of v2 from this equation to this equation, and from there we get m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v1 plus u1 minus u2. Solve this equation, and if we solve it, then m1 v1 plus m2 v1 is equal to u1 into m1 minus m2 plus u2 into m2 plus m2. So from there we get m1 plus m2 v1 is equal to m1 minus m2 u1 plus twice m2 u2, and from there we get v1 is equal to m1 minus m2 divided by m1 plus m2 into u1 plus twice m2 u2 divided by m1 plus m2. So clearly the velocity of mass 1 after collision is given by this formula. Now if I put the value of v1 in the equation, v2 is equal to v1 plus u1 minus u2, we get the value of v2 also, and the value of v2 comes equal to m2 minus m1 divided by m1 plus m2 into plus twice m1 u1 divided by m1 plus m2. So how we will remember this formula? First thing, that whenever you write v1, then first write m1 minus m2, and here it should be m2, while if you write v2, then it's m2 minus m1, and here it should be m1. So in this way you can recall this, you can recall this formula, that is the velocity of ball after elastic collision. Now we will learn special cases of elastic collision, and first thing is that if the projectile and target are of the same masses, that is both colliding body is of the same mass, that is m1 is equal to m2. So if m1 is equal to m2, then the first term will become equal to 0, and if I put the value of m1 is equal to m2 in this equation, then if you see that v1 is equal to 0 plus twice m2 divided by twice m2 into u2, and from there we get v1 is equal to u2. As m1 is equal to m2, so we directly put here in the denominator m1 is equal to m2, and similarly we get v2 is equal to u1. So clearly when two bodies of equal masses undergo head-on elastic collision, their velocities get interchanged. It's a very important concept, that for the elastic collision between two bodies having same mass, their velocity just exchanged. So it is shown in this figure also, that here two balls of 10 kgs are moving with velocity 50 meter per second and 20 meter per second respectively. After the collision, if it is an elastic head-on collision, then the velocity becomes equal to 20 and 50 respectively. So you may see very clearly that here the velocity gets interchanged. Now we are taking the sub case of this when u2 is equal to 0, that is when the target will be in the rest. So if its body is equal to u1 and here u2 is equal to 0, target is in the rest and masses are same, then after collision, this is the case of before collision, and after the collision this m, it's a, suppose it's body A, it's body B, having both having mass m. So this body A comes in the rest. So here velocity is equal to g1 is equal to 0 for this body A, and this body B which was in rest earlier, so it will started moving with a velocity u1. So it's written here that when u2 is equal to 0, that is target at rest, then the velocity v1 is equal to 0, that is the velocity of first body will be equal to 0 after collision, and the second body will start moving with a velocity equal to first body. Now